Okay, so today we'll have a variety of topics to discuss. We'll first go into the various causes of forgetting. We'll talk about context reinstatement, defining that it's better to remember something if you can reinstate the original context in which you learned something. And that suggests that there's a rich interaction between encoding and retrieval. And then we'll switch gears, something very different, and talk about some individuals that have remarkable, or more like exceptional memory performance. We'll talk about some individuals that have synesthesia. Their brain is just wired differently and can remember seemingly arbitrary amounts of material. We'll talk about people with hyperthymesia, people that remember everything that have happened in their own personal lives. So let's go into it. So remember the stage theory of memory, where there's some hypothetical stages, different memory stores, and various processes can transfer information from one store to the other. So if you think about forgetting, forgetting according to this theory can occur because information never reached long-term memory. So perhaps the information was in sensory memory at some point, but wasn't transferred to short-term memory because it wasn't attended sufficiently. That's one reason of forgetting. The information could be in short-term memory at some point. You might have been rehearsing a phone number, but maybe not sufficiently. And so the information, again, never reached long-term memory through some encoding process. The most likely source of forgetting is that the information is in long-term memory, but you just fail to get it out. Your retrieval cues might be insufficient. So here's a list of various possibilities of forgetting in long-term memory. So again, one possibility is that there's inadequate encoding. The information somehow never reached long-term memory to begin with. The second one is decay. It's possible that the mere passage of time can lead memory traces to decay. And researchers believe that that might influence forgetting to some degree, but it doesn't play a huge factor. The passage of time by itself is often not a good explanation for forgetting. Other things have to happen for things to be forgotten. And one of the most likely causes of forgetting is interference. The information is in memory, but something else is interfering with that memory. Some memory is learned before the event that you're trying to retrieve or after the event. And they're similar somehow, so your memories are competing for attention, if you will, and you're consistently retrieving the wrong thing from memory. And finally, one possibility is distortion. So because of your interpretation of events, your verbal interpretation, your own background that you bring to a situation, you might gradually modify your memories over time to suit your interpretation. And then the original interpretation is gone. So one person who systematically studied forgetting and how forgetting takes place over time is Hermann Ebbinghaus. So he did this a long time ago, at the end of the 19th century, and he was basically the first experimental psychologist. He didn't really have an extensive lab with a lot of students. He was his own subject in some classic memory experiments. So he wanted to know what the effect is of the retention interval on memory. So the retention interval is the interval between learning or studying and the moment of retrieval. And intuitively, one would expect that the longer the retention interval, the more you forget, right? So there has to be some relationship between increasing the retention interval and the amount of forgetting that takes place. But he wanted to know exactly what is that relationship? What does it look like? So he put himself as a subject through some extensive experiments. So he had a metronome, excuse me, he had a metronome where he was timing the presentation of stimuli, where he was rehearsing at a regular interval. And he was studying nonsense syllables, 3-letter words, doesn't mean anything like box, dat, vox, because he wanted to know how good your memory is for things that you don't have any prior knowledge about, so that prior knowledge doesn't contaminate the effects. And then he waited after each study period for some amount of time, that was the retention interval, and then he tested himself, not with recognition or recall, but with something that he called percent savings. That's the vertical axis on this graph. His idea was your memory could be much better than what a recognition or recall test would indicate. So what he did is he studied something until he was perfect at remembering these nonsense syllables, waited a while, that was the retention interval, and then he was measuring how long it would take himself to retrain himself on the original list. And then he had this measure percent savings. If it was 100, he already knew all the nonsense syllables, and he didn't need to be retrained. If it was 0, then it meant he needed the same amount of time, the same amount of rehearsal as the original list to get himself back up to perfect performance. Now this is the classic retention interval curve that he found. And you can see that initially, in the first hour or even the first few minutes after you study something, there's rapid forgetting. There's an enormous amount of stuff that you forget. But then there's a negative acceleration in this curve. And at some point, it doesn't matter how long you make the retention interval, there's always some percent savings. There's always some stuff that you remember long term, presumably because it's transferred to long-term memory. So there's always some residual memory, no matter how long the retention interval. That's one of the classic findings in forgetting. Now, this retention curve, this applies to just about anything you can test yourself on. Arbitrary information, personal events in your life. But there's some interesting exceptions. Typically, your memory for everyday events, things that happen to you, gets worse over time. So if I test you on events that happened a week ago, you're better than if I test you on events that happened a year ago. But there's an exception, and that's called the Reminiscence Bump. If I go further back in time, your memory gets worse. But if I hit you, if I ask you about events that happened in early adulthood, in adolescence, your memory gets actually better. Your memory is actually improving for events around this period of time. So in this hypothetical curve shows this reminiscence bump. So if we test a 55-year-old on memory for events, so this person is here on the time scale, and now we go back in time. The first part of the curve on the right-hand side shows the classic sort of retention curve, right? So if you go back in time, memory gets worse. But then it bumps up again, that's the reminiscence bump. And it peaks around 18, 22 years of age. And it's kind of a curious finding. Why would this be? And we don't quite know why we get a reminiscence bump. There are two main explanations. One is a primacy effect. In your early adulthood, there's a lot of first things that you do. Right? First time you go to college, first time you drive a car, first time you have a serious relationship, etc., etc. Those things you remember. You remember those very well because they're the first time they happen. And there's some evidence for this primacy explanation. Because for some individuals, the first things are shifted in life. For example, immigrants that arrive in the US in their late 20s or early 30s, they have a lot of firsts later in life. And their reminiscence bump is actually shifted. So that suggests that primacy is one important explanation. The other explanation is just your brain functions pretty much optimally in early adulthood. So perhaps you just remember better because your brain is just in an optimal state, so to speak. Everything goes downhill from there. Does this make sense, the reminiscence bump? Yes?
Wait, what was the second reason?
The second reason is neurological. So your brain is just in its most healthy state, right? It's most optimally functioning around your early 20s. So you remember better because your brain is just functioning very well. Okay, one of the main reasons of forgetting is interference. Every time we do a memory experiment and a subject seems to have forgotten information, there's always clever ways to try to probe memory using different retrieval cues to show that there actually was some residual memory, but something else was competing with that memory. It was interfering with that memory. So the book confusingly calls this an effect of new learning. And I think a better term is just this interference. Memories interfering with other memories. So how do we know that interference is a good explanation for forgetting? Well, the book mentions a very clever experiment where members of a rugby team are asked to recall names of other people on other rugby teams, depending on how long ago they played that particular team. So sometimes people were asked about games that were played 17 games ago. Sometimes it was the last game. Not surprisingly, people's memory is better if you're asked about more recent games, like who were those people on those games that you played, the last time. And the results are a little noisy, but you see this rough shape of a forgetting curve. Right? More recent memories are better. But the critical part here is that they try to control for the mere passage of time. So they did an analysis where they looked at players that had the same number of intervening games. So they probed, let's say, people for memories for things that happened 7 games ago. But for some people, this happened a longer time ago than others, because some people didn't play all games. And they found that the effect of time didn't really play much of a role in explaining forgetting. So if you just control for the number of interfering events, then time is irrelevant, almost irrelevant, not quite. What matters is just how much other things have gone on since the last time since the event that you're trying to remember. So interference, that's the key. So if most causes of forgetting are due to retrieval failures, there are ways to improve your memory by using what's called context reinstatement. So during encoding, you're not only encoding the actual information about the event, you're also encoding your interpretation, any association with the event, how you feel, what other things you're thinking about. All that information might get encoded, integrated with the event itself that you're trying to memorize. then at retrieval, it helps to reinstate that context, reinstate all those extraneous things that you might have been thinking about or feeling about in order to retrieve that original event. And the better you can reinstate that original context, the better you are in remembering the information. Now, how do we know this? Well, a classic experiment by Goblin Valley, kind of an extreme experiment, expensive setup. It hasn't been replicated as far as I know, because it's such a pain to do this experiment. They tested deep sea divers on their memory for random lists of words. And they had these scuba divers study words either on land or while they were underwater. So there were two different study conditions, and there were two different testing conditions that were manipulated independently. So either they were tested for these random words while they are on land or while they are underwater. And the results in this graph on the right show a classic interaction effect. In fact, it's a crossover interaction effect. It's a very powerful finding where the subjects that were studied the material on land, they were better if they were also tested on land. They did less well underwater. But the subjects that studied underwater, which could be much more stressful in many ways, they were better if they were tested again underwater than if they were tested on land. So if the test conditions matched the study conditions, memory was optimal. Now, why could this be? Well, it could be a number of factors. Maybe when you're underwater, you're thinking about different things. You're thinking about water, you're thinking about breathing, you're thinking about a lot of things. And when you think about those things, same things again, when you're tested underwater, maybe that helps your memory. And when you're tested in a slightly different condition, maybe you don't quite have the same retrieval cues that can help you out. Yes?
Does that also fall in line with primacy as well? Because it would be almost a new experience, an experience that is different from what you're actually used to.
That's interesting. But that would not explain the interaction effect. I agree that it's an extreme thing to be studying something underwater. Maybe remember it very well because it's underwater, right? But these results show that you're worse when you're then tested on land later on. So primacy can affect sort of the general levels of memory, but it cannot explain the interaction effect. Yes? Okay, there's some other findings. So the last slide that's basically from the book, but there's some interesting other experiments that are not reported in the book. It turns out that your physical state matters, how you feel. And it might help to reinstate your physical state as best as possible. Here's an experiment where subjects were studying words when they were happy or sad. How did they do this? Well, they asked subjects, what kind of music makes you sad? What kinds of music makes you happy? And then they were studying words under this sad music or happy music. And then they were tested again under happy and sad music. And you see this crossover interaction pattern again. The subjects that were, so on the red curve, the subjects that learned stuff when they were happy, they could best recall that stuff when they were listening to the happy music. On the other hand, in the blue curve, the subjects that were learning while they were listening to sad music, they can mostly, they were much better in recall when they were again listening to the sad music. It's kind of an interesting effect. Now here's a study that you can't do very easily anymore. This was done in the 1970s when there were fewer restrictions on the kinds of things you could do with subjects. This would be difficult to get approved by the IRB. They had subjects either smoking a regular cigarette or a marijuana cigarette during study, and then they were tested when they were smoking a regular cigarette or tested under the influence. And you can see in the top row, subjects that just smoked an ordinary cigarette, their recall was best when they were just smoking a regular cigarette under testing conditions, 25% as opposed to 20%. Well, maybe just being high makes you just worse in memory. On the other hand, the subjects that were high during study, presumably high, their recall was best when they were high again at test, 23%. Again, it's a very similar sort of interaction pattern. Now, there's a nice lesson here. For those of you who were high during study for an exam, you might as well show up high again for the test. That seems scientific. But for those of you who have a choice to be high or not high during study, remember that overall, on average, so these two numbers, your performance is worse overall, right? But if you have no choice, you might as well show up high again. They did these studies also with alcohol, and the very simple finding, those subjects that studied while on the influence of alcohol, they just did poorly. Period. Okay, now there's a related, so far we talked about sort of different ways to retrieve information by reinstating the context as best as possible. And there's a related finding called the spacing effect. And this has important consequences for how you study for tests. You probably know that you shouldn't cram for an exam. So if you have a choice and you have a lot of things to study, it is better to space out all these different things over time and not sort of repeat the same thing over and over and over again and then move to something else. So it's better to interleave your study experiences. If you're studying for 3 things, study 1, 2, 3, 1, 2, 3, 1, 2, 3, as opposed to 1, 1, 1, 2, 2, 2, 3, 3, 3. Sort of repeating the same thing after you just finished it. But there's a very tricky research finding that a lot of people are not aware of this. Because it seems like you're doing better by cramming, by massing the repetitions. So this graph shows, these are people, I think, that were studying language pairs, so English words coupled with their translations into another language. And on the right-hand side, or sorry, the left-hand side shows the performance on a memory test if you're tested immediately. So right after you study the last pair of foreign words, what happens if you're tested immediately? Well, you can see that the solid black dot is better. So when you're massing your repetitions, you're better than actually when you're spacing the repetitions. So when you're testing yourself right after you are studying, you are under the illusion that you're better by cramming. And indeed, you're better on short-term memory retention when you have massed repetitions. But it's just an illusion because under delayed memory conditions, real-world conditions, right? The point of memory is to hold on for something for a longer time. It's always better to space your repetitions. And why is that? Well, presumably when you interleave the material, there are different ways in which you think about the material. Right? Every time when you look at it again and you just looked at something very different, you think about it in new ways. And all those new ways in which you encode that same information can help set up retrieval paths that help you later at retrieval time. And that's one explanation for spacing effect. You want to think about the material in many different ways. You're going to create many different types of associations. Does that make sense? Okay. So now we make a go to a very different topic. There are some very famous cases, but individuals that don't seem to forget anything. And you really wonder how they do that. And I'll show you a number of different cases, very different types of people. The very first case of somebody who seemingly can remember anything is patient S. And it's described in this book. It's a wonderful book by Luria. He's one of the first neurologists, somebody who wanted to understand sort of how somebody's brain is working. And so he wrote this book, The Mind of a Mnemonist. So patient S came to him to get himself tested and checked out because he felt he was very different from anybody else. He was already working as a mnemonist, somebody who performed basically at parties for money because you could present him any sort of list of arbitrary stuff and he would remember it. And his first job was as a journalist, and he was quickly fired as a journalist because the editor was annoyed that he never took notes. Everybody else was taking notes, but not S. And the editor later asked him, like, what were you doing? Everybody's furiously scribbling, and you were not doing that. And he could remember anything that the editor said at any point in time. So his memory is virtually limitless. He studied the medieval text of the Divina Commedia, which is this sort of old Italian text. But S didn't even speak Italian. He memorized each individual word in sequence, which is an amazing feat. And so he had a capability of synesthesia. This is the first, I think, one of the first documented cases. Synesthesia is a case where your sensory modalities are fused, where you can hear the things that you see the things that you hear. You can touch smells, you can smell touch. It's very difficult to explain. But these people build these very complex associations that allow them to see very simple things in very complex ways. So for them, a sequence of numbers or a sequence of words creates this enormously complex pattern of sensory impressions. And that allows them to remember a lot better than most other people. Now, I should say that it sounds great to have a perfect memory, but this person was not a very happy person. He couldn't even answer very simple questions. His general knowledge was quite poor. He seemingly was unable to generalize because he was constantly focusing on the detail, never filtering out the irrelevant stuff. So his inductive reasoning was quite poor. So some people would say it's good to have some limitations in memory because it forces you to generalize. Now, there is a person who might be similar in many ways to patient S, and he's still alive today. He's quite amazing. We'll show a video on the next slide. So he's described in a book, an autobiography, Born on a Blue Day. That's shown on the top right. I highly recommend reading that book. So Daniel Tammet has Asperger's syndrome. So he had difficulty understanding other people, difficulty reading social cues, understanding facial expressions. And he tried to overcome this. He tried to will himself into sort of trying to understand other people, and he did a good job. He gives speeches nowadays, and he's quite eloquent. And he's one of those rare individuals. There might be only 50 people like Daniel Tammet on Earth that has synesthesia in the way that he has it. So Daniel Tammet has a version of synesthesia where it's not only the sensory modalities are fused, his whole concepts of numbers and words, his linguistic knowledge is all merged with sensory impressions. So I made these slides, I made some changes to the slides this morning, so you might not see this if you downloaded the slides before 9 a.m. But here at the bottom, here's some artistic impressions on how Daniel Tammet sees or considers the number 1, 5, 11, and 89. And an artist basically created these impressions. So for Daniel Tammet, 1 is like a big bang white shining. 5 is a loud clanging thunderous number. So he describes numbers in terms of sounds as well as various visual impressions. Pi, so you'll see in the video that he tried to memorize thousands and thousands of digits of pi. And for him, pi is a beautiful number because it evokes this visual landscape. It's very hard to understand what's going on here, but in his brain, if he thinks about pi, he visualizes this landscape. And that allows him to remember very large sequences of digits associated with the number pi. He can also do amazing mental calculations. How he does it is very difficult to understand. So 53 times 131, he would immediately give an answer. Right? He's one of those savants that it's just there, the answer. He sees the answer. And this is his visualization of this calculation. 53 times 131, well, of course, that looks like this. Hard to understand. So let's show a video of some of the amazing things that Daniel Tammet has done. That's not good. Well, we could do YouTube, but hopefully we won't get a commercial.
Here's Nick Watt with Brain Man.
31-year-old Daniel Tammet is, outside, unremarkable young man. Well, like Clark Kent, who behind those glasses hides the powers of Superman. Behind Tammet's bookish exterior lies a superhuman gift, one of the most extraordinary brains our planet has ever seen. Scientists have tested Tammet's memory. They had him take a look at pi, a string of numbers that goes on forever.
You read through them once?
Yeah.
And that was it, you memorized?
And that was it, one time only.
He memorized the first 22,000 digits of pi.
4, 1, 5, 9.
And then, in front of a disbelieving audience, he begins reciting the numbers back in order from memory.
5, 7.
5 mathematicians struggling to keep up, checking every single digit.
2, 5, 9, 0. 3, 4, 6, 9, 0. 8, 1, 9, 9, 0.
After 5 hours and 9 minutes.
Finished. Yeah.
Every single one. Perfect.
I learned to count like anyone else at a young age. And when I did, I would see colours, I would see pictures in my mind. I assumed at the time that everyone saw numbers as I did.
Tammet didn't do math like the teacher said. The answers just came to him. Watch how he finds the answer to 53 times 131.
With a sum like 53, round, very round, after at the bottom, and then you've got another number here, 131, which is longer, a little bit like an hourglass, symmetrical, and in the middle you've got a negative space, then you have a third shape, and this I see as the solution to the sum 6, 9, 4, 3.
With Tammet, every digit is a 3-dimensional shape. 9 is large, deep blue, concave. 4 is small, light blue, angular. 10 is like puzzle. To memorize a long number like pi, he just forms a beautiful landscape out of those shapes.
It's a world, it's a novel world.
A world science cannot fully understand. Hannah has Asperger's syndrome, a form of autism that makes him unnaturally obsessive, focused. He also has something called synesthesia. In a normal brain, different parts don't talk to each other. In Tamek's brain, they do. That's why he sees numbers as beautiful shapes and colors. They call Tamek an autistic savant, like Brain Man.
Do you know how much the square root of 2,130 is?
46.15.9 204.
Most savants, like Dustin Hoffman's character, find normal life social interaction almost impossible.
Were you bullied at school? Yes. I would have gestures, clapping of the hands, for example, walking in circles. And the other children would repeat that back to me, tease me, call me names.
But these days, crowds flock to hear Tamek speak.
The most extraordinary brain is named Daniel Tamek.
I realised, that I had something within me that was special and was a gift, and I should use it to the best of my ability to make a difference.
His autobiography is a bestseller, translated into 20 languages. A second book details how our brains really work.
I'm able to look from the inside out, and so that gives a new perspective that scientists haven't had before.
Tamek is also a role model for having overcome the crippling limitations of autism.
It's never easy. I mean, I think there's always an effort there.
He trained himself to make friends, jokes, stuff that for most of us is second nature.
But he still can't drive a car. What's the obstacle there? The obstacle there is the amount of detail that my brain can pick up. And it's beautiful, but it's not safe for driving.
Tamek, born the eldest of 9 children in England, now lives in Avignon in the south of France, where popes lived in the 14th century. Van Gogh painted the surrounding countryside.
There's meat, cheese.
He's embraced the French joie de vivre.
We eat lots of fish. Very good for the brain.
I'm sure you need it.
Who knows?
Because not only are numbers a gift, but so are words. He knows 8 languages, and we want him to pick up one more. Off to Reykjavik, Iceland, where Tamek touches down with the final challenge to learn Icelandic, perhaps the most impenetrable language on Earth. For example, remember the name of that Icelandic volcano that was in the news? He'll have 1 week to learn the language.
Impossible for a human to learn this in a week.
When people say to me, this is something you can't do, I want to do it. I want to prove them wrong.
It was like a walking picture. I can see he was sucking up the words, and he was just putting it in his brain.
After just 7 days of studying, as he cracked the code, Tamek appeared on Icelandic TV, a live talk show.
You're back. It says fiddly soulfully.
Holy cow, he nailed it.
It's not human.
No, it's not. Daniel Tamek is superhuman, and science can't quite figure out why.
So, Daniel, the question everyone wants to ask you is, how do you pronounce the name of that Icelandic volcano? That's hard.
Yeah, so what do you think? Any comments about Daniel Tamek? Have you seen this before? Yeah. Yeah, I highly recommend reading his books. It's quite amazing. I still don't understand how he did that mental calculation. Didn't make a lot of sense to me. There's another group of individuals, and these are not synesthetes. They're normal in I guess, many ways. And they were only recently discovered. They were discovered here at UCI. So James McGaw, shown here on the bottom left, he's a distinguished professor who founded the Center for Neurobiology of Learning and Memory. And he discovered, along with some colleagues, these individuals that have a highly superior autobiographical memory. People that have near perfect memory for personal events in their lives, but not much else. So ask them about a date, and these individuals will say what day of the week that date falls on. And they can also answer anything that happened sort of on that day as they experienced it. They're not autistic, they're not savants, they're not synesthetes. They don't appear to use any specialized mnemonic strategies. So they seem normal in many ways, but they can't forget anything that happened to them. And let's see, if this video doesn't work, I'll have to there's a short segment from 60 Minutes that I extracted. And it doesn't work. So I'll say, let's watch this in your own time. The individuals were quizzed on various news events. Initially there was some suspicion that these subjects, they were just playing tricks or they memorized the answers. So they were tested in the lab under very careful conditions. It's like what happened on 1973, 8th of March. And this woman, AJ, she's the famous one, she was the first one that was discovered. She could vividly describe what she did during that day. And she could also retrieve details that were incompatible. So she remembered, for example, weather patterns during that day. And it turned out, people first thought that some of these answers were wrong because they looked at the answer in some encyclopedia or online weather reports, and it turned out the online reports were wrong. The encyclopedia was wrong. After some fact-checking, it turns out this woman was right. And now people believe that these subjects have near-perfect memory. So they have very good memory for autobiographical events. But they're not special on any other test. So if you test them on recall for, let's say, a random list of words or numbers, their memory is about as good as anybody else. They're also not immune to memory distortions. So occasionally they remember things that are not quite right. They remember their interpretation or their association. They can have false memories. Some of these individuals, if you look at the video, they look like they're a bit OCD. They're obsessive about keeping track of things happening in their lives. And various brain scans have been conducted of these individuals. Surprisingly, the standard brain areas involved in memory, the hippocampus, the prefrontal cortex, we'll talk about the hippocampus on Thursday, they were normal, not enlarged at all. The only brain areas that were different were the caudate nucleus and the temporal lobe. And the caudate nucleus is interesting because this is where habits are learned. And one hypothesis is that these people are compelled to remember. They have just an obsession with remembering things because of this enlarged caudate nucleus. That's just an hypothesis. It's not clear if this is true because it's just a correlation. They just happen to have these enlarged areas. We don't know if that causes their superior memories. And so research is still going on about why do they have such good memories. Yeah, and I highly recommend seeing that video clip. It's quite amazing. And there's a question in the back.
Did Daniel Hammett have any like significant enlargements in his brain or anything like that? Did they test his brain?
It's a great question. I think his brain was tested, and so I believe he just had the standard finding of what synesthetes have. So connections between brain areas that other subjects don't have. So most people think that it's his synesthesia that explains his superior abilities, right? His ways of fusing, ways of organizing information that you and I cannot do, right? Because our brain areas are not communicating in that way, right? But these subjects here, they're not synesthetes. Yeah. The last group of individuals that are special are so-called memory athletes. Has anybody read the book Moonwalking with Einstein? It's a popular science book. It appeared a couple of years ago. And it documents this person, Joshua Furr, who describes himself as a regular person with no specific abilities, training for the US national championships, the memory championships. So he talks with other individuals who have competed in these memory championships, and he describes all the various tricks, the tricks of the trade. And it's mostly an exercise in forming very complex associations, as rich as you can. Often, the more hilarious the associations you can develop, the more crude it is, the better you're able to remember sort of the arbitrary list of words or numbers that are part of these memory championships. So here are some of these records that are established in these championships. So these are just amazing things. Within 5 minutes of study, people can remember 1,080 digits, the binary digit span. In 30 minutes, they can remember 4,000 digits, long sequences of cards, 300 random words within 15 minutes. These people do amazing things, but they don't, as far as we can tell, their brains are not different from normals. They just use good memory strategies. So here are some examples of these people that compete either in the US national championships or the world championships. And some of these people were tested in the lab on some of these paradigms that we've talked about. So they were tested on the DRM paradigm, the Diess-Roediger-McDermott paradigm. And the results are that these memory athletes, they have superior discrimination abilities. They are much better to discriminate between things that are on the list and things that are not on the list. So this graph on the right shows that for items that are on the list, these memory athletes recall many items, whereas things that are not on the list, like the sleep word on the sleep list, they can successfully sort of suppress those false memories. Whereas controls have a much harder time. So controls are fooled by these words like sleep on the sleep list, and their false memories are much higher in this case than the actual list items. So that's one difference between these memory athletes and control subjects who are of the same age and background. Another interesting task that they tested these memory athletes on was the Stroop Task. So can I ask somebody to name can I ask you to name the colors? So what color is the word printed in?
Green, orange, yellow, gray, green.
You've seen this probably before, right? So sometimes there's a conflict between the ink color and the word. And it's the famous Stroop Task to test how much you can suppress automatic sort of reading, your response is based on just reading the word automatically, versus focusing on this sort of odd task of reading out the color of the ink that the word is printed in. So when these memory athletes were tested, it was found you get a classic Stroop effect for control subjects. So control subjects are slower on these incongruent pairs, right? If the word blue is printed in yellow. And so this difference between this gray bar and the white bar, that's how much you're slowed down by having these incongruent word pairs. Now these memory athletes, they're much quicker overall, and the difference between these congruent and incongruent pairs is much smaller. They have much better control, attentional control over things. So that's yet another difference between these people. So to summarize, so when these memory athletes were tested on various laboratory tasks, they showed exceptional performance, even on ones that they have never seen. So this suggests that their training generalized to some extent to other tasks. And these superior memory groups, they all showed better attentional control, as measured by Stroop interference, than a college control group. So their focus is overall much better. And researchers are still studying sort of what makes these people sort of perform so well. But it's believed that their brains are just standard and that they just are more motivated to participate in these kinds of events. All right. Then one little mystery that I want to end with. I don't know the answer. This is a recent news report. Some of you play Scrabble, you know the game of Scrabble. So this summer, the Scrabble championships were held in French. And this guy, he won that event. Now he actually doesn't speak French. He's from New Zealand, so his native language is English. And he memorized the entire French Scrabble dictionary, which contains 368,000 words, in 9 weeks. Nobody's ever tested this guy before in the lab. He's kind of a recluse. So one question I want to leave you with, how did he do this? Is his brain different? Did he use special tricks? What do you think? So let me know if you have a thought on that, and I'll see you on Thursday.